So let's try to go for okay, yes. Okay, so let's try to go for some problem based on Hamiltonian. So first I will solve that problem which I have given you homework, and then we will try to solve some very basic problem just to understand how to write Hamiltonian to Lagrangian or how to write Lagrangian to Hamiltonian. So this is the thing we are just going to discuss in next half an hour or 45 minutes. And tomorrow's class will be again a combination class will of Lagrangian and Hamiltonian. So uh, let's try to go for a first problem. So in the last class, I have given you homework. So Lagrangian in the polar coordinate is given as half m r dot square plus r square theta dot square minus half k r square. So this is our Lagrangian of a system. And we have to write the Hamiltonian. So how many generalized coordinate is there? There are two generalized coordinate. One is r and other is theta. So the Hamiltonian of a system is basically function of generalized coordinate r. So it will function of r theta conjugate momentum pr p theta. And it may be function of time, but if Lagrangian is not a function of time, then obviously Hamiltonian will also not a function of time. So this can be written as, so you have r dot pr. This is my first generalized coordinate and generalized momentum. Second will be theta dot p theta. And now we have to go for Lagrangian, and this is my Lagrangian L. And this can be written as r dot pr plus theta dot p theta minus half m r dot square minus half, and that value is m r square theta dot square plus half kr square. Now, some people just leave this thing just like this, but this is not a Hamiltonian unless until you are not going to replace this r dot with pr and p theta. You have to replace r dot and theta dot with pr and p theta. So for that, we have to use the Lagrangian of a system. So from here, we can use del L upon del r dot is equal to pr, and that value is mr dot. So we can easily find that value. And this r dot can be replaced with pr by m. And similarly, we have to go for del L upon del theta dot is equal to p theta, and this value is mr square theta dot, and from here we can get theta dot is equal to p theta square upon m r square. Now we will put each and everything into this particular equation. I think, okay, sorry. Okay, good. So you have to put this r dot and theta dot in this equation. So when you will put r dot and theta dot, so this value is basically pr square upon 2m, and this is p theta square, sorry, pr square upon m actually, not 2m, pr square upon m, and this is p theta square upon mr square minus half m, and what is r dot square is pr upon m whole square minus half m r square, and theta dot square is basically p theta square upon mr square plus half kr square. Now, and pr square, and this will be also square. And now what you can do, you can just calculate all this thing, and what you will get? You will get the Hamiltonian of system, and this is basically pr square upon 2m plus p theta square upon 2m r square plus half kr square. So this is my absolute Hamiltonian of a system. So you have to, this is very trivial problem, not a very tough, but yes, you have to, if you want to learn this thing to basic understanding of Hamiltonian, this is a wonderful problem. So now you can see that we have to go for writing the equation of motion for Hamiltonian equation of motion. So we have to just write it for r, theta, pr, as well as p theta, as well as for time. So let's go for the r part. Up to that, everyone is comfortable? यहाँ तक सारे लोग comfortable हो?
Yes, sir.
Yes,
Okay.
sir.
Okay. So let's try to go for the first equation is del h upon del r is nothing but minus pr dot. So when we will go for del h upon del r, so this value is nothing p theta square upon mr cube, minus sign is there. This r cube minus 2 will we go to minus 3, and 2 and 2 will cancel out. So minus 3 sign is there, and plus kr is equal to minus pr dot. So this is our first equation, and then we have to just go for, okay, now we will go for the second equation. So I can use this space. Yes, I can use this space. So this here we have go for del h upon del pr is equal to nothing but r dot. And when we will go for del h upon del pr, this value is pr upon m is equal to r dot. And you can see this is the exactly same equation whatever we have get in this particular part, isn't it? हो रहा है ना? Same equation you can find. So whatever the information we have in the Lagrangian, we are just going to preserve it. This is very interesting. And next we have to just go for theta part. So I can use this particular space. So when we will go for del h upon del theta, this value is minus p theta dot. And this is basically del h upon del theta is equal to 0 is basically minus p theta dot, which implies p theta is nothing but constant of motion. And you can also see that theta is cyclic coordinate from the Lagrangian, and we again verify yes, theta is cyclic coordinate, so why p theta is going to conserve. So whatever the information you are getting from the Lagrangian, you are just going to preserve it from the Hamiltonian formulation. This is very important thing. And last but not the least, we can use this particular space. इसको यहाँ use कर लेते हैं. Okay. So in this particular space, we have del h upon del p theta is equal to theta dot. And from here, we can find, so p theta upon mr square is equal to theta dot. So from here, you will again get the same equation what we are getting from here. Last but not the least, what you can find? You can find that del h upon del t is equal to 0. So dh upon dt is equal to actually del h upon del t, which implies h is conserved, and we can identify this h is nothing but the total energy of a system. So everyone is comfortable? So I think these all questions I have asked in your homework, and some people have done it absolutely correct. So any question? It's okay? Okay. So let's go for a next problem. So this is a very simple topic. So examiner will always ask you, they will give you Lagrangian, and then you have to find the Hamiltonian. Again, they will give you Hamiltonian, and you can find easily Lagrangian of a system. Okay. So let's go for next problem. So here we have write the Hamiltonian from Lagrangian. Now we will try to write Lagrangian from Hamiltonian. If someone will give you Hamiltonian, how you will write the Lagrangian of a system. So this is also very interesting. Let's try to go for this. So what we have, the Hamiltonian of a system is basically root under p square plus 1. So let us assume this is my Hamiltonian of a system, and q and p are the generalized coordinate and generalized momentum. So this is my Hamiltonian, and what we have to do, we have to write the Lagrangian of a system. So now how you will go for it? This is very important. So now it is the trend that they are giving you Hamiltonian, and then you have to go for the Lagrangian of a system. So let's try to go for it. So how we will go for it? So we know that Hamiltonian of a system is nothing but PQ dot. So there is only one generalized coordinate. So there is not any problem. We can use it. So Q is the generalized coordinate. P is the conjugate momentum. So PQ dot minus L. And we can write this L as a function of generalized coordinate, generalized velocity, and time. And this can be written as PQ dot minus H. And here this H is basically function of generalized coordinate, generalized momentum, and it may be function of time. So what we have to do? We have to just replace here generalized velocity. Sorry, we have to just replace here generalized momentum to generalized velocity, isn't it? Because Lagrangian is actually function of generalized coordinate, generalized velocity, and time. So what we have to do, we have to just replace it. As suppose we want to write the Hamiltonian as a function. Suppose Lagrangian is given and we want to write the Hamiltonian, then what is going to happen? Which quantity we have to replace? कोई बताओगे किसे replace करना है यहाँ पर?
Generalized velocity.
Generalized velocity को किससे replace करना है?
Generalized momentum.
Generalized momentum से किस equation के through replace करना है?
Del.
ये very good. Del L upon del Q dot is equal to P. इस equation के through replace करना है. So we will just try to solve this particular problem. So how we will do it? So we have to use Hamiltonian equation of motion. So यहाँ पर किस equation का use करना होगा जरा बताओ? इसमें किसे replace करना होगा हमें? Generalized momentum को replace करना होगा. So अगर हमें generalized momentum को replace करना है तो किस equation का use करेंगे? Anyone?
Del H by del
P.
Very good. Del H upon del P is equal to what? Q dot. है ना? So हमें लेके जाना होगा del H upon del P is equal to Q dot. And what we have to do? We have to write P as a function of generalized coordinate and generalized velocity. यही idea है ना? So let's try to do it. This is a very nice problem. This is a wonderful problem. So Lagrangian of a system is generalized coordinate, generalized velocity, and time. And this will be PQ dot minus root under P square plus 1. And what we have to do? We have to replace P with Q with function of Q or Q dot. So let's try to solve it here. So del H upon del P, this is my P. So I think this value is P upon P square plus 1 to the power half. आप चेक करो मैंने सही किया या नहीं? Just check it.
Yes, sir.
सही किया ना? 2 और half दोनों कैंसिल हो गया, ठीक है? Okay. And this can be written as P is equal to Q dot P square plus 1 to the power half. And what we have to do? We have to make it a square. So दोनों तरफ square कर लेंगे. P square is equal to Q dot square P square plus 1. And what we can do? We can write P square as 1 minus q dot square upon q dot square. Yes, and from here we will just try to write p is equal to, so p is basically q dot 1 minus q dot square to the power half, isn't it? यही होगा ना? This p is positive quantity, don't worry. Why it is positive quantity I will tell you later, but just look at this thing. Am I correct? सही लिखा हूं?
Yes, sir.
Okay, now we are just going to put it in this equation. So this p can be replaced by q dot 1 minus q dot square to the power half into q dot, ये वाला q dot है, माइनस रूट अंडर p स्क्वायर की जगह पर क्या लिखे? q dot square 1 minus q dot square, and this half है, this square will cancel, plus 1. Now अब आप इसको ऐसे नहीं छोड़ सकते हो. Are you the real challenge into your exam that you have to write it in a compact form? चलो ये काम तो हमारा हो गया कि आपने मोमेंटम को वेलोसिटी से रिप्लेस कर दिया, एंड बट यू हैव टू राइट इट इन अ वेरी कॉम्पैक्ट फॉर्म, एंड दिस इज द रियल चैलेंज इनटू एग्जाम. कि यहां तक तो हर कोई स्टूडेंट कर लेता है, बट उसके बाद कैसे शॉर्ट में लिखें, चीजों को कैसे कॉम्पैक्ट करें कि हमारा आंसर जो है गिवन 4 ऑप्शन से मैच कर सके. सो यू हैव टू ऑलवेज टेक केयर ऑफ दिस पर्टिकुलर स्टेप, और यहीं पर सबसे ज्यादा गलती होने के चांसेस होते हैं. सो प्लीज टेक केयर in the examination. Okay, so what we are going to do, we will just so we can use this particular thing as, so this value is what? Q dot square, this is my Lagrangian, 1 minus Q dot square to the power half minus, ये पूरा पार्ट क्या हो जाएगा? Is that Q dot square will cancel, so we have 1 by 1 minus Q dot square to the power half. आप यहां भी नहीं छोड़ सकते हो, you have to go for next step. So when you are writing this particular thing, then we have q dot square minus 1 minus q dot square to the power half, and now this can be written as, you can write minus 1 minus q dot square to the power half. So this is my Lagrangian of a system. Are you getting it?
Yes, sir.
Now अब ये किस चीज का हैमिल्टोनियन था वो थोड़ा देखते हैं, है ना? So you remember that your relativistic energy E is given by what? P square C square plus m naught square C4, है ना? 1/2. याद है? अगर आपने नहीं है तो इतना तो जानते होगे. The relativistic energy is given this thing. So what is, so ये जो प्रॉब्लम है इसको रिप्लेस किया गया बेसिकली C is equal to 1 and m naught is equal to 1 को देकर, and what is this value? This value is nothing but mod p square. So this is the magnitude of momentum. So why we are taking the positive sign there. So you have to always take care of all these things. ठीक है?
Yes, sir.
है ना? So always take care of this particular thing. चलो, so let's go for next problem. ठीक है?
Yes, sir.
So अब मैं आपके लिए होमवर्क दे दूं, नेक्स्ट होमवर्क दे देता हूं. So if this is my Lagrangian of a system, and what is Lagrangian? 1 plus q dot square to the power half, find the Hamiltonian. find the Hamiltonian. This is your homework. Okay, and we will go for next problem. ठीक है, चलो. And this is one of the very nice problem, one of the very fundamental problem. इसको हम जरा करने की कोशिश करते हैं. ये आपके एग्जाम में भी आया हुआ है. सो पहले लैग्रेंजियन से हैमिल्टोनियन करेंगे एंड देन वी विल गो फॉर हैमिल्टोनियन टू लैग्रेंजियन फॉर सेम थिंग. ओके, ताकि पूरी की पूरी तरह से प्रैक्टिस हो जाए. एंड ऑलवेज बी वेरी मच केयरफुल when this type of problem is there. Okay, so let me write the problem correctly. So Lagrangian of a system is given by half m x dot square minus m x dot y dot. So this is my Lagrangian of a system. So if this is my Lagrangian of a system, what we have to do? We have to write the Hamiltonian of a system. So this is your Lagrangian and you have to just go for Hamiltonian of a system. Good. Look at the most important part. आप जरा इसमें बताओ, इसमें real challenge क्या है? Anyone? इन जनरल आप देखोगे कि जितने भी हम लैग्रेंजियन करते हैं, लैग्रेंजियन से हैमिल्टोनियन, हैमिल्टोनियन से लैग्रेंज, दैट इज वेरी स्ट्रेट फॉरवर्ड. व्हाट इज रियल चैलेंज? यहां पर क्या परेशानी वाली चीज है जिसका हमेशा टेक केयर करना पड़ेगा आपको?
नॉन लीनियर.
नॉन लीनियर नहीं, नॉन लीनियर क्या है?
कपल टर्म.
हाँ,
कपल टर्म.
कपल टर्म. वेरी गुड. यू कैन सी दिस टर्म. देखो, जहां भी कपल टर्म आ जाए, एक्स डॉट वाई डॉट वाली चीजें आ जाए, सो दिस विल रियली क्रिएट अ प्रॉब्लम. किस चीज में प्रॉब्लम क्रिएट करेगा ये भी बताओ.
सम मोमेंटम सेग्रीगेशन.
नहीं, मोमेंटम रिलेशन हो तो ठीक है, तुम पहले कर चुके हो इस प्रॉब्लम को, इसलिए बात कर रहे हो. एक्चुअल आप चीजें नहीं पकड़ रहे हो. किस चीज में प्रॉब्लम क्रिएट करेगा? एनीवन? बताइए, किस चीज में ये प्रॉब्लम क्रिएट करेगा?
जब हम मोमेंटम निकालेंगे तो वाई डॉट का टर्म और एक्स डॉट का टर्म भी साथ साथ आता है.
एग्जैक्टली. तो एक लैंग्वेज में आप ये कहोगे कि वेरिएबल और सेपरेबल में की प्रॉब्लम क्रिएट करेगा. समझ रहे हो बात? कि एक्स की सारी पार्ट को सेपरेट करना वाई से बहुत ही ज्यादा टफ होगा. क्लियर है ये? तो उसके लिए हमें आगे क्या व्यवस्था करते हैं, दैट इज डिफरेंट इशू. बट वेन एवर दिस टाइप ऑफ थिंग इज देयर, always it will create a problem and you have to take care of this type of problem और आपको patience रखना होगा. So let's try to solve it. Okay, so first हम लोग solve करते हैं. So how many generalized coordinate is there? Obviously 2 generalized coordinate. So what we have Hamiltonian is equal to x dot px plus next is y dot py minus Lagrangian, and this can be written as x dot px plus y dot py minus half m x dot square plus m x dot y dot. Now what is the next challenge? x dot y dot को हमें रिप्लेस करना है. किससे रिप्लेस करना है? px और py से. आपके एग्जाम में दिया रहेगा कि x and y are the generalized coordinate and px and py are the conjugate momentum. So x के साथ px, y के साथ py, इस तरह से आपके एग्जाम में चीजें दी रहेगी. And then we have to solve the problem. Clear है ये? Okay. So let's try to go for this one. इसको हम लोग सॉल्व करने की कोशिश करते हैं। चलो, सो फर्स्ट वी हैव टू गो फॉर डेल एल अपॉन डेल एक्स डॉट, इसकी वैल्यू क्या होगी?
Px.
That value is px. So what is this value? You can write m x dot minus m y dot is equal to px. So you have x dot minus y dot is equal to px upon m. My goodness. आप देख रहे हो चीजें? अभी तक क्या था कि x dot को डायरेक्ट लिख देते थे, लेकिन यहां पर इसे काम नहीं चल रहा है. Let's try to go for another one. जब हम नेक्स्ट वन पर जा रहे हैं, then what you have? You have del L upon del y dot is equal to py, and fortunately यहां पर क्या हो रहा है, del L upon del y dot अगर ले जा रहे हो तो क्या मिल रहा है आपको? माइनस m x डॉट इज इक्वल टू py, और x डॉट की वैल्यू क्या होगी? माइनस py बाई m. This is a very different thing. And now you will put x dot here and then you can get the y dot. So आप जिस तरह से चीजें सोच रहे हो कि डायरेक्टली लिख लें कि x डॉट के जगह पर px by m लिख लें, y डॉट के जगह पर py by m लिख लें, this is not true here. And this problem is actually created by this particular coupling term. So whenever this type of coupling term will come into picture, be always conscious. Always try to make extra effort to solve the problem. Okay, now, but this is not so tough. So we can replace x dot here. So when we will replace x dot, then what will be happen to y dot? So x dot is equal to minus py upon m minus y dot is equal to px upon m. And what you can do, you can write y dot is equal to px plus py by m, and we can take negative sign here. Now, this exercise is very important, and you can assume in the examination pressure how you will handle this thing. This is not so easy. So you have to take care of each and every point. Okay? In spite of the problem of Hamiltonian is very simple, but yes, sometime you have to keep patience to solve the problem. This is very important. So now let's try to solve it. तो आप मुझे गाइड करना, मैं अगर कहीं गलत कर रहा हूं तो. So x डॉट की जगह पर क्या पुट कर दें? माइनस py upon m. px is there. प्लस y डॉट की जगह पर क्या पुट कर दें? माइनस px plus py upon m and py minus half x डॉट की जगह पर क्या आ जाएगा? Square term will be gone. So p y square upon m minus, यहां पर दोनों ही दोनों टर्म रहेंगे, माइनस माइनस प्लस, so this will be m x डॉट की जगह पर py upon m and y डॉट की जगह पर हम चीजों को ले जाएंगे, and then
Px plus Py.
क्या आ जाएगा? px plus py, है ना?
Sir.
देख लेना कहीं मैं गलत तो नहीं कर रहा हूं, है ना? So this will be px plus py by m. माइनस माइनस प्लस साइन, तो ये दोनों ये सही रहेगा. ठीक कर रहा हूं?
Yes, sir.
Okay. Now let's try to go for this. So first term is minus px py upon m. Second term is minus px py upon m minus py square upon m minus py square upon 2m. And here 1m will cancel. We have plus px py upon m plus py square upon m. Great. Is that something is going to cancel out? Yes.
Yes, sir.
So this py square upon m and this py square upon m is cancel out. And what is another part? The another part is this, and this can be also cancel out. So what will we answer? The Hamiltonian is basically minus px py upon m plus py square upon 2m. This will be my Hamiltonian. I don't know which system it is going to represent, but yes, if this is my Lagrangian, then this is my Hamiltonian of a system. And when people are try to guess this particular problem, then it is not going to guess it very easily. Everyone is comfortable?
Yes, sir.
Okay. So you can see how we can use this particular term Hamiltonian to Lagrangian and Lagrangian to Hamiltonian. So why didn't you go for a homework for this one? Just verify we have done it correct. So suppose this is your Hamiltonian. Find the Lagrangian. हो जाएगा? Find the Lagrangian. Okay. So this is again homework number 2. Please try to do it always. Whenever I will give you homework, please do it. Please do it, because this thing can only help you to upgrade your level. So step by step, you can go for next level and next level and next level. So this is just a routine type problem, and you have one particular day. You can just go and solve different types of problems. Okay. So tomorrow I will go for a previous year papers of Lagrangian and Hamiltonian. Those questions which are really little bit of different league problem. Mainly we will try to use the differential equation in both in Hamiltonian as well as in Lagrangian. So tomorrow we will complete all this part. Okay, but before that you can just go for your this particular booklet and try to solve all the Lagrangian to Hamiltonian and Hamiltonian to Lagrangian. Okay, if you have any doubt, then please let me know.
सर आज जो हमने फर्स्ट क्वेश्चन किया था जो कल होमवर्क मिला था,
बिल्कुल
सर उसमें आप एनर्जी कंजर्वेशन बता दो, मतलब
उसमें एनर्जी कंजर्वेशन आपने ये देखा डेल एच अपॉन डेल टी की वैल्यू क्या है? 0 है।
यस सर।
आ रहा था। और
yes,
हैमिल्टोनियन के लिए आप लिख सकते हो डी एच अपॉन डी टी इज इक्वल टू डेल एच अपॉन डेल टी. This is equal to 0?
Yes.
Okay. That means H is identified as constant of
Yes,
motion. ठीक
yes,
है? Okay. अब हमारा जो हैमिल्टोनियन निकला था वो हैमिल्टोनियन क्या था? This is nothing. PR square upon 2m and P theta square upon 2mr square plus half kr square. ठीक है? यही निकला था ना? है ना? Yes या no? चलो, I think there is some problem. So what is this? This is translation kinetic energy. This is rotational kinetic energy. And this is potential energy. So what you have actually? What is this Hamiltonian? This Hamiltonian is nothing but kinetic energy plus potential energy, and which is nothing identified as total mechanical energy of a system. And this Hamiltonian is going to conserve. So what is going to conserve is that total energy of a system. Yes?
Yes, sir.
है ना? अभी जिस स्टूडेंट ने पूछा था मैं उनसे बात कर रहा हूँ. Are you comfortable? Okay, I think she missed the link. Anyway, so this is your first level of problem and second level of problem where this is routine problem. You will have Lagrangian, you will just write to Hamiltonian. You have Hamiltonian, just write to Lagrangian. Tomorrow, we will go for next level of problem where we will try to use equation of motion and solve the time evolution of a state So कल हम लोग कुछ नए प्रॉब्लम करेंगे. And also I will try to find out the action of a system, generalized generalized force of if you have some potential is given, how you will find the generalized force and all these kind of problems. Okay, and tomorrow we will finish the Hamiltonian and Lagrangian, and then we will go for the actual part, and that is the understanding the symmetry with the Poisson bracket, canonical transformation, and generating function. Okay, thank you.
Thank you, sir.
Thank you, sir.